Now in this video, we're going to be discussing our royal honesty, the Deep Agents harness. What's really inside? What's really inside this operating system that LangChain has created for agents and has made a Deep Agents package out of? Like I mentioned in the previous video, the harness is a collection of built-in capabilities that turn a basic agent loop into something that can handle real-world complexity. So it's basically an agentic operating system. But in this video, we're going to be looking at each component in the harness. This might be the longest video in this section, or this or the next one. I don't know how much I'm going to get into the details, but we're going to be looking at the different components in the harness, and I think I have 9 of them. that we're going to be going through. But without wasting time, let us get started. The first one is planning. I think I will try to do 2 per slide. So let's say planning. The first one is planning, the ability to plan. Deep agents come with a planning feature. They come with a planning feature, and that is powered by a built-in tool called write to-dos. A built-in tool called write to-dos is actually a tool that the agent calls. Let me put this planning inside a box so that just distinguishes it, as a section. Good. So it comes with a write to-dos tool. The agent calls this tool, uses it to create and manage a structured task list. Creates and manages a structured task list. Let us have that somewhere here too. So this tool creates and manages a structured task list. That's what write to dos does. It creates and manages a structured task list. So when you give your deep agent a task, it's going to call this tool, and it's going to break down. This is going to break down that task. Let's say you tell it, book me a flight. Then it's going to call this tool, and this tool will do something like, okay, search for the top booking flight sites. So it's going to make a list of them. So he writes that, search for the top booking flight, then pick one based on certain criteria. I'm going to pick one of them. Then it's going to also tell itself, read the site to understand how you can perform a booking. Then from there, it will say, make a booking. Then finally, send a notification that you are done. So it just makes those plans. It just writes those plans. But it doesn't just write them. It doesn't just write them. For each plan, it attaches a status. For each plan, it attaches a status. For each plan on the list, it attaches a status to each one of them. And this status can be pending. We also have the in progress status. And we have the completed status. So at any state of any task on the list, it can attach any of these status. It can attach any of these status to the individual tasks and monitor the tasks as they are done. And it will keep solving the task one by one, making sure that one task is completed before going to the next task. That is if they are not to be run in parallel. It's going to do all that management for you. You don't have to track all that. It's going to write a plan and manage how they are executed by tracking the status. And also, it persists this in the agent state. This task list is persisted in the agent state. So it will survive across multiple turns. If you keep calling the agent and keep having the same conversation, it will maintain that task list to understand everything that it has done. So it does that all for you. It does all that for you. It gives the agent the ability to break down a complex task into discrete trackable steps before and while executing them. So before executing the complex task, it breaks it down. And even while executing them, it still creates subtasks in between tasks if needed. And it manages all that for you, which is just amazing, which is just simply amazing. Because without planning, agents tend to wander. They wander and jump between subtasks, lose track of what they've done and all that. But the to-do list keeps them guided. It acts as the agent's internal project management board. So that's the first thing you get in the harness. The second thing is a virtual file system. A virtual file system. And this is just an amazing piece. This is just an amazing piece. You get a virtual file system. This virtual file system consists of various file system operation tools. So you get things like the ls command, the read file command, the write file command, and edit file command. Yes, you can edit files. Edit file command, you even get glob and grep. You get all these guys to interact with your files, and the agent can just call them like any other tool. You get all these file system tools out of the box, and the agent can call them like any other tool. Now, these tools don't hit a hard-coded disk location. They don't hit a hard-coded disk location. Instead, they hit what is called a backend. They hit what is called a backend. Yeah, a backend. A backend. And backends are just amazing. They hit what is called a backend. These are pluggable storage layers that determines where the file will live. So you get all these file system tools, and you get to decide where they will live. You get to decide where they will live. They can live on your file system. They can live in a database. They can live in the agent state. They can even live in a sandbox. You can plug any type of backend to your file system. You can plug any type of backend to this file system. And here, you don't even need to worry about which particular backend you're using. You just use all these tools. You just use all these tools, and they help you manage your files. And you can decide where or what the storage layer is going to be. We have a full video coming up where we'll be discussing all the available backends. The backend that exists in state, which just stays in memory, tied to a current conversation, a file system backend, a storage backend backed by a LangGraph store, the database, even a composite backend where you get to route different requests to different types of backend. Yeah, you can have an hybrid setup where you route different artifacts, different file contents to different backends. You can have that. And even the sandbox backend, a sandbox backend that you can use to run operations in isolated environments. Yeah, we have a whole video dedicated to that, so don't worry, we'll scratch that itch. Now, this file system is the agent scratch pad. It's basically the agent scratch pad and storage system that lives outside the context window. It lives outside the context window, and it helps you manage a lot of voluminous and bloated conversations. For example, instead of keeping a 10,000 line data analysis result in the conversation, the agent will just simply write it to a file in the backend. It's going to write it to a file in the backend, and whenever it needs any part of it, it can read it out. It can go to read that piece, that particular piece it needs from the whole volume of information, to just read it using any of these system file system tools, and read it into the agent's context window based on the agent's needs. Yeah, that's how you get rid of a whole lot of information that you don't need right now, but you might need some of it later. It manages all that for you, so you have every single information still in place, but not clogging up your context window. You're not clogging up your context window. And anytime you can swap your backend, you can control where it lives, whether in memory, on a disk, in a cloud store, or even an isolated sandbox. So yeah, this is the beauty of backends. And because backends are pluggable, the same agent code can run in memory for a quick prototype. It can run on a local disk for a CLI tool, or inside a sandbox for a production coding assistant, without changing a single tool call. You don't need to change anything on this layer. But like I said, there's a whole video dedicated to backends, and we're going to be treating that very, very soon. The next harness feature we're going to be discussing is context management. Context management. Context management, and this is really powerful. This is one of the places where you see the full power of the virtual file system and your backends. Now, context management is all about managing your context window. It's all about managing what goes into your context window. And we have two automatic middleware processes that run behind the scenes during the agent loop. The first one is offloading. offloading. That's the first context management strategy. Now, what happens in offloading is that the harness is watching for tool inputs or results. It's watching for tool inputs or results. Now, any input or result that exceeds a configurable token threshold, let's say 20,000 tokens, and I think 20,000 tokens is the default. If it exceeds that, it just swaps them for file system pointers. It swaps them for file system pointers. So let's take a look at this. Let's say this is our agent. Let's say this is our agent. This is our agent, and this is our file system. We have our file system here. Now, the agent just received. Let's put a tool somewhere around here. Let's put a tool around here. So this is our tool. Now, the agent just received an input from a tool. Received an input from a tool, but it contains 20,000 tokens or 40,000 tokens. That is too much. That is too much for the context window. That's too much for the context window. So what the harness is going to do is that instead of having all that information, let's represent all that information with this. Instead of having all that information inside here, instead of having it inside here, it would put it in the file system. To put all that information in the file system and replace that information here with a pointer. Going to replace it with a pointer to the file system. Going to replace it with a pointer to the file system. So instead of having the agent keep all this information inside the context window, what it keeps is a pointer to the file system. And this pointer can be used to reference this information at any given time, or parts of this information that are needed at any given time. Yep, that's basically how it operates. It doesn't put the entire 20,000, 40,000 token feedback into the agent's context window to bloat it up. No, it offloads it to the file system and it returns a pointer that can be used to reference that information. So that's the first strategy, offloading. That's how offloading works. The other strategy is what is called summarization. Summarization. The other context management strategy is called summarization. Summarization. Now, what happens in summarization? Summarization is basically like a watcher. The summarization system is like a watcher on your context window. It's watching your overall conversation, watching it as it progresses. Then once it crosses approximately 85% of the agent's context window. Once it crosses that, what the harness is going to do is that it's going to compress older messages. It's going to compress older messages into a structured summary. So you have conversations going on and on, and it's starting to hit that 85% threshold. So what the harness does is that it takes that entire conversation. Let's say this is the entire conversation. It takes that entire conversation and creates a summarized version of it. It takes it and creates a summarized version of that conversation and puts it in the context window. It puts the summary inside here, but still keeps the full thing for reference. It still keeps the full thing, it still preserves it for reference. But what it keeps inside here is a structured summary of the entire conversation. So with this, the agent has a summarized version to always include in the context window for reference, and it can always contact the full history anytime it needs a certain part of it in detail. Yeah, that's basically what context management or summarization in context management is all about. Once our conversation history is eating 85% of the context window, whatever the context window is, a structured summary is generated, and the full conversation itself is dumped into the file system. By the way, let me put file system here so that we can know what this guy is. File system. Good. So it's put in the file system, and we have a reference to it. How amazing is that? These two processes, offloading, which creates pointers to results, and summarization, which summarizes the entire conversation in the context window and gives us a summary and puts the full thing in the file system, they help us keep the working memory of our agent lean. They keep it lean without losing information, because we still have all the information in the file system and we can always reference it. They keep it lean without losing information. And this is done automatically for you and managed automatically. So it's not only done automatically, it is managed automatically. If the conversation continues to grow again after the summarization, it continues to grow and grow and grow, another summarization operation is going to kick in. Large tool outputs get stored as files. The agent can read them later. An old conversation history gets compressed into a summary, and the agent can always search the original through the file system. Awesome, awesome, awesome. This is arguably the most critical piece of the harness. Without it, long-running agents will simply crash. They would crash. They can't run for long without this system, because this is the system that manages all the tasks done so far and all the information gathered and the limited context window. This is what manages everything. This is how long-running agents can go for hours, can go for days, because they don't crash or degrade when they hit their context limit, because we have context management going on. The agent can work for hundreds of turns without losing track. So context management has already filled up this entire frame, so we'll have to go to another frame to discuss our next feature. The next feature we're going to be discussing is the sub-agents feature. Sub-agents. The harness also allows you to have sub-agents, and these are agents that you can delegate tasks to. So while the main deep agent is working and it realizes that it needs to delegate a task, it can just spawn a fresh isolated agent instance, which is a sub-agent, and that sub-agent can go and do what it does and return information. Now this is done through another tool that comes out of the box with deep agents, known as the task tool. Yeah, there's a task tool that deep agents come in that the main agent can use to spawn a fresh isolated agent instance. So whenever the deep agent needs a sub-agent, this is the tool it calls, and that tool is going to spin up that particular sub-agent. Go to spin up that sub-agent. Now these sub-agents have or run in their own isolated environment. They run in their own isolated environment. So basically, they have their own context window, they run autonomously until they are done, and they return a single final result to the agent. They return a single final result to the main agent. Every information about what they've done remains within them. Every detail is kept within the sub-agent, and the sub-agent only returns a summary, the final result of what it has done. We're going to be having another video dedicated to sub-agents, so I'm not going to be going too deep, but we're going to get the gist from this video. So let's continue. Now, sub-agents allow the main agent, I think at this time I need to put a main agent here. Let me just put main agent. This is the main agent with a task tool. Yeah. So we have main agent here. So sub-agents basically allow the main agent to delegate specific tasks. For example, research this topic, review this code. They can delegate it to a child agent, and that agent works independently and reports back with a summary. Emphasis on with a summary. Reports back with a summary. It doesn't come back and bloat the main agent with all the details of his research. Because one of the reasons why we have sub-agents in the first place is because we are trying to solve the context bloat problem. A lot of times agents have to browse the web, they have to review stuff, and before you know it, they clog up the context window with a bunch of review details or web search data. We want to give that to sub-agents to do. They can keep all that information within them, summarize everything, and just return a summary to us. Just return what we need, just the highlights, and we can just go ahead with that. Actionable items only. That's what we need from sub-agents. And with that, we keep the context window lean. If a research task requires, let's say, 20 web searches, all that intermediate data stays with the sub-agent. The main agent will only see a clean summary. So yeah, that's sub-agents. So we've seen sub-agents. The next thing we will discuss is code execution. Code execution, which is another great and important feature of the harness. Deep agents help us to run code. They help us to run code, and that can be done in two ways. First is by using our local shell as a backend. Like I said, later on we're going to have a video on backend, so you understand how all this works. Using our local shell as a backend, or using a sandboxed backend. So with either of these two, we get something called the execute command. Once we use any of these backends, we get an execute command. We get this execute command, and it helps us run code in our harness. The local shell is going to run code directly on our system. If we use our local shell as a backend, it's going to run code directly on our system, in our system's CLI. If we use a sandboxed backend, we get to use different providers like Modal, Daytona, or Run Loop to create a sandboxed backend, and all our code executions will run inside that backend. It's going to run inside that backend. And whenever we run this execute command, what we get back is a standard output or standard error. We get our exit code, and we also get a summarized version or a truncated version of our output. This is to help us manage our context window so that it doesn't just dump the entire output back to us, but it keeps it for reference. Yeah, it keeps it for reference. We can still reference that output. So we get standard out or standard error, we get our exit code, and we get a truncated output because we're trying to manage the context window. That's what we get when we run the execute command. So this feature basically lets our agent run commands in a terminal. The agent can install packages, it can run scripts, it can execute code, and it can interact with a full Linux environment. All isolated from our system. That's when we use sandboxes. If we use sandboxes, it interacts with the full Linux environment. If we use our shell command, it's interacting with our direct environment. And later on, we're going to be seeing how we should take caution when we are using our local shell. But sandbox environment, very, very safe. Very, very safe. We can run operations like data analysis, coding assistance, we can test pipelines. All these require running code. So this code execution feature just makes all that possible. So that's code execution. I think we can have two on this particular frame. The next is human in the loop. HITL. Human in the loop. Human in the loop. Now, your human in the loop feature is your guardrail or safeguard against running actions that can be very, very disastrous if it goes wrong. Irreversible actions, deleting files, deleting stuff from databases, updating stuff in databases. You want to introduce some human in the loop mechanism into that. So the harness provides a way for you to do that. You can interrupt on editing files. You can interrupt on writing files. By the way, let me start putting something on the screen there. So you can interrupt on editing. You can interrupt on updating files. Reading files is safe, so that might not cost you anything. You can interrupt on executing. You can interrupt on executing commands. So oftentimes you want to configure an approval. Approve before editing, approve before executing, and you can reject. Whenever the harness tries to run that command, execution will pause. You take your action, whether to approve, reject, or even edit information that is going into that tool. And once you're done, control goes back to your application, and whatever decision that you have made is going to be the one that is respected. So human in the loop, very, very important for running safe operations. It adds safety gates at specific points in the agent's workflow. It ensures that you have that human element inside for reviews, for approvals of sensitive operations before they execute. Because we've read the stories. We've seen agents deleting people's databases, agents deleting people's drives. There was even this I think Meta's head of safety, yeah, recently Meta's head of safety was using OpenClaw, and it was deleting emails, and she was even telling it, don't delete, I told you not to delete. And you know how these agents reply in the most polite way, almost as if they are passive aggressive, saying, oh, sorry, yeah, you did tell me not to do that, I'm sorry I did that, let me tell you how we can reverse that, or I'm sorry, that cannot be reversed. Like, it's often very, very weird the way these agents can go off the rails. So a lot of operations are irreversible and high stakes: deleting files, sending emails, making API calls that cost money. You want to make sure that you add a human in the loop checkpoint where it matters the most, and without slowing down the other safe operations that the agent needs to perform, like reading files. Those are safe, so you almost don't always need to add a human in the loop stopgap when you are reading files. So yeah, human in the loop, that's another amazing feature that comes with the harness. The next, and I'm still going to keep managing this space. First, let us help ourselves visually by adding some colors here to note our features. Then down here, I'm going to put long-term memory, which is the next feature we're going to be discussing. Long-term memory. Long-term memory. Now, I've already discussed a lot of what this does under context management, because this is actually even on the documentation, this is listed under context management, but I just decided to have it separately so that we can just talk about it a little bit. Now, this is basically a pattern that is built on top of your backend, and these are backends that are configured with a store backend. These are file systems that are configured with a store backend. That's out there here. Configured with a store backend. We're going to be looking at backends much later, so you know what a store backend is. But just for quick understanding, a store backend is a LangGraph store that is backed up by something like the in-memory store, or that's for development, then Postgres store for production. So anytime you are backing up, anytime you are creating a backend with a store, with a LangGraph store, that is how you set up long-term memory. You have long-term memory set up that way. And if you remember, like I said, you can have an hybrid setup, so you can set up some of your information to go into ephemeral memory, which is the state, and you can set some to go into your more stable backends like your file system or your store backend. So your store backend is how you configure long-term memory for Deep Agents. Files get written to this store backend, and they get to persist across not just conversations but also across threads, across different threads. So you can, even if you come another day and start a new thread, those information are still going to be there. They are still going to be there. Like I said, we'll be discussing more on backends later, but I just want to note this as another feature that you get: long-term memory when you set up a store backend. This setup will enable your agents to save and retrieve information, things like user preferences, progress of a particular task, accumulated knowledge over time, all this information that needs to survive a single conversation thread. Yeah, they stay in your long-term memory. Without this, all of your conversations are going to start from zero. But with it, an agent can remember important things like I said, user preferences, accumulated knowledge. These are things that you want to store and have your agent remember them anytime you come back. Even when you restart your agent, you still want this information to be there, because these are information that has been built over time, or information that are specific to how your user wants to use the agent. Now let us discuss the last two features that the harness gives to us. Yeah, last two features. And the number 8 feature is skills. Yeah, skills. You've heard about skills, skill.md. Yeah, this is the guy. Now, what is a skill? A skill is basically a directory. It's a directory. That's what it is here. Let's say directory. So a skill is a directory containing, first and foremost, a skill.md file. A skill.md file. So it contains a skill.md file. Let me put this here. The directory, it contains a skill.md file. So your typical agent skill standard. You have your front matter data, which is things like what the skill is, the description of the skill, what it does, and stuff like that, instructions. And you also have optional files, supporting files like scripts. You can have scripts inside this folder. You can have scripts. You can have templates. You can have templates. You can have scripts. You can have templates. You can also have reference docs. Yeah, you can also have docs here, all to support the task that your skill is supposed to perform as defined in this skill.md file. So yeah, that's basically what the skill is. You can check out the agent skills standard. Let's see, agent skills.io. That's where you find the agent skills standard. So yeah, you can check out how to create skills on this website. Awesome resource for learning how to create skills. So you can see how everything that it contains. You see skill.md file, scripts, references, assets like templates and resources and all stuff like that. A directory where you build a particular skill. So yeah, you have that, and whenever the agent starts, it will first read that front matter data from each skill. Like I said, every skill.md file, let's get something like that in there. Let's say this is your skill.md file. It will contain that front matter data. And that front matter data is basically things like your name, like name of your skill, the name of your skill. You have the description of your skill, the name, description of your skill, and stuff like that. Let's check out some of them here. Let's see, skill.md file. Yeah, stuff like this. So this is your front matter data. So this is the first thing that the agent is going to read when it starts. It's going to read this from every skill file. It's just going to read this. It's not going to read all these guys. It's going to just read this. It's going to read that front matter data. Now, when it receives a prompt that matches a skill description, it will then read the full content of that skill description. That's when it reads the full content of that script description and loads the full content and even all the scripts and resources and all stuff. Is a process known as progressive disclosure. So it doesn't need to read all this file. It doesn't read the entire file or the entire content of the skill folder at once. When the agent starts, it reads this front matter data, and with it, you can quickly get what the skill means. It's just like when you're creating tools. When you're creating tools, your doc string, that's the front matter data for your tools. So this is the front matter data for your skill, which the agent is going to read when it starts. When it is now prompted and it sees that, oh yeah, this prompt would require this skill, it will now load the skill and any other relevant information from the skills folder. So yeah, that's how the harness manages your skills. It provides the agent with a specialized on-demand domain knowledge and workflows. Like for example, you can create skills on how to query a Postgres schema, how to fetch the LangGraph documentation, how to fetch your company's knowledge base, and you can do all that. And with this process I just defined, you won't bloat the system prompt. Because all you are reading at first, at startup, is front matter data. And with that, you don't cram every possible instruction into the system prompt. So yeah, skills. Let's give that a background color too. Skills would help you package expertise separately and load them when they are relevant. And with the loading mechanism that the harness adopts, you get to save on tokens and keep your agent highly focused. So yeah, that is skills. Lastly, we're going to look at memory files. Let's give that yellow. Say memory files. Memory files, that's the ninth feature we're going to be looking at in the harness. Now, what are memory files? Now, these are one or more files. Typically, these files are named agents.md. Let's see, agents.md. And these files are typically passed to the memory parameter. There's a memory parameter on your deep agent. So this is where these files are passed to. Now, unlike skill files, which use the progressive disclosure system that we discussed, that's reading front matter first, and then when the skill is needed, you load the entire thing. Memory files are always loaded into the agent's prompt at startup. the entire thing, the entire content of the agents.md file is loaded as startup because they contain persistent context that you want to be taken into account for every turn, for every thread, for every conversation you're having with your agent. You want these instructions to be persistent. So things like coding style preferences for coding agents, project conventions, user guidelines, things that should apply to every single interaction. This is where you store them. They help you establish a consistent baseline of preferences and knowledge that the agent applies in every conversation. So anything you would know has to apply to every conversation without the user having to repeat themselves. This is where you put it. Inside that agents.md file. These memory files help you to define how your agent should behave, how it should always behave. There are places for things like, always use TypeScript. Let's say you are writing a project that you know you're going to be writing JavaScript, but you want it to always be written in TypeScript. Say always use TypeScript. Or let's say our API uses snake case, or the user prefers short, concise responses. This is where you store those type of instructions. And one fantastic thing about these files is that as the agent is operating, the agent can keep updating this file. Which is just pretty cool. Based on feedback from interactions, from memory, from different things that your agent is learning, it can continue to update this file. And what is going on at that moment is that the agent is self-improving itself. Is improving itself by itself. So anytime it's learning something new, getting new instructions, it would update this file by itself, and the agent will become smarter. You just go and open this file and you see that it has added more instructions, it has added more stuff that it needs to take into account. So yeah, that's something that is pretty amazing. Can also be a bit or rather you should be cautious about it if the agent goes to add some feedback that you don't want to be persistent. But yeah, it's just amazing that agents can collect information and update these files with those information, and automatically it makes them improve over time, which is just simply awesome. So yeah, this is the harness. Your agent loop is still simple. It's still think, act, observe, and repeat. The same process: think, act, observe, repeat. Think, act, observe, repeat. But now each of those steps has infrastructure supporting it. The infrastructure of the harness, the operating system called the harness. Planning guides the thinking, the file system supports acting, context management ensures nothing is lost, and sub agents continue to keep things clean. And that's just amazing.